Assalamu alaikum. Welcome to my YouTube channel, Be Natural Love Creator. Today we learn about buffering in soil. Soil also exhibit buffering action, exhibit meaning, প্রদর্শক. Soil also exhibit buffering action in order to why they produce buffering action in order to produce a certain change of pH. It is usually necessary to add much more acid or alkali. Why it is necessary? It is necessary to add much more alkali or much more acid or alkali than the amount of hydrogen and hydroxyl ion in the soil suspension would lead us to expect. What is buffering action? Buffering action is resistant to change in pH. While we add much acid or alkali, it don't change its pH. It is due to the influence of weak acid and the salt. Why? Buffering occur into the soil due to influence of weak acid and the salt. Carbonates, bicarbonates and phosphate are present in the soil and act as buffering agent. So what are buffering agent in the soil? Carbonate, bicarbonate and phosphates. More important than these, the colloidal complex is acid with cation act as a strong buffering agent. What is a strong buffering agent? Which is a strong buffering agent? Colloidal complex with associated cations. Now, organic acid are continuously being formed in the soil as a result of microbial activity. How those acids are continuously formed in the soil? Due to microbial activity. Those acids are weak acid and provide excellent buffering agent. Buffering agent is weak acid. Similarly, the colloidal complex, both organic and inorganic, can be represented as being made up of negative acetoid and absorbed cation. So how those colloid complex made of? The colloid complex made up of a negative acid and absorbed cation. Negative acetoid and a cation. Acetoid and a cation made a buffering colloidal complex, and this colloidal complex is a strong buffering agent. In humid and subhumid region, calcium and hydrogen cation are most numerous. So which is most numerous cation in humid and subhumid region? What is most numerous absorbed ion in humid and subhumid region? Calcium and hydrogen cation. Their probable dissociation is represented as follow. You can see in those reaction of buffering reaction in the soil. Hydrogen ion also release slowly from the exchange complex and provide reserve acidity. These hydrogen ion are available in soil. This is potential acidity. And what is active acidity? When hydrogen ion neutralized by alkyl substances. So how neutralized H plus or hydrogen ion in soil when alkaline substances added. More of hydrogen ion are released, thus affecting little change in pH. When hydrogen ion released more and when hydrogen ion combined with complex. Hydrogen ion released more when alkaline substances added to the soil. and if acidic substances added to the soil, it combined with exchange complex. Thus, little change in hydrogen ion concentration or pH of soil solution take place. The colloidal complex is similar to mixture of weak acid and their salt, and weak acid and their salt is buffering agent, and it is functional buffering exactly the same way as acidic acid and sodium acetate solution. We know acetic acid and sodium acetate is very common buffer solution. The basic of buffer capacity soil lies in the reserve hydrogen of the exchange complex and its associated metallic cation. Basic buffering capacity lies on reserve hydrogen and metallic cation. Now, this is the next slide. Importance of buffering in agriculture. The significance of soil buffer to agriculture is mainly twofold: the stabilization of soil pH and the amount of amendment necessary to effect in a certain change in soil. Let's see the first point, the stabilization of soil pH. Stabilization means the process of making something physically more secure or stable. So, make pH stable is the reason of buffering in soil. Now, number 2, the amount of amendment. Amendment meaning sangshodon necessary to affect a certain change in soil pH. Necessary to affect certain change in pH. Stabilization of pH and the amount of amendment necessary to affect the change in soil reaction. A sudden change in pH causes a radical modification in soil condition, and if this environment should fluctuate widely, meaning fluctuate widely, this situation is fluctuate widely as might be the case with an unbuffered medium. Higher plant and microorganism would suffer seriously. In the unbuffered medium, higher plant and microorganism would suffer seriously. Change in soil reaction not only have a direct influences on the plant but also exert an indirect influences on soil environment by creating sudden changes in the availability of nutrients. So those sudden changes make availability of nutrients. Deficiencies. In case of deficiencies, certain plant nutrients we know the toxic amount would seriously upset the nutritional balance in the soil, and the change in the soil pH should be made gradually at the time of year, and biological upset is likely to be least serious and succeed during a period when no crop is growing. If this is occur, no crop is growing, and the amount of amendment necessary to affect a given alternation in soil reaction also relate to the effectiveness of pH stabilization. The amount of amendment necessary to affect a given alteration in the soil reaction also relate to effectiveness of soil pH. pH stabilization. So what buffering does? Buffering does also soil pH stabilization. The greater the buffering capacity of the soil, the larger must be the amount of lime and sulfur to affect a given change in pH. Buffering capacity. Although pH gives some idea as to the active acidity or alkalinity, and to a certain extent the base saturation, it gives no idea of buffering capacity of the soil. The buffering capacity depends mainly on the amount and the nature of clay and the organic matter content. So, buffering capacity mainly depend on what? Depend on the amount of and nature of clay and organic matter content. Not pH of soil. And if we decide to apply some lime, what should we see? pH, soil texture, soil type, and organic matter of soil. Thank you for watching this slide. Now we solve some question about soil buffer. Strong buffering agent is, which is the strong buffering agent? Colloidal complex. Confirm. Humid and subhumid region, most used buffering ion is in humid and subhumid region. Most buffering ion is calcium and hydrogen ion. Next, calcium 2 plus ion increase when we add little acid. Buffering meaning resistant to change in pH. Hydrogen ion increase adding when we add when we add alkaline, then hydrogen ion increase. Buffering agent is, which is buffering agent? Oh, how acid form in the soil due to microbial activity. Excess hydrogen ion removed by exchange complex. Basing buffering capacity of the soil line on hydrogen ion and cation both. Thanks for watching this channel.